Good morning, friends. In today's lectures, we are on the topics of the organic chemistry, unit 4th, that is natural products. In that, we are going to study the synthesis of the citral from methyl heptanes. Step first, synthesis of the methyl heptanes. Methyl heptanes, one all is dehydrated and the bromine is added to the product, which is condensed with the sodium salt of the acetyl acetone, is hydrolyzed with the alkyl to get the methyl heptanes. Here the reactions beta-methyl butane 1-all anhydrous ZnCl2 form the unsaturations, gives the addition of Br2 on these compounds. On the addition of the Br2, we will get the products. On this, add the acetyl sodium ketone groups. By adding this, we will get the products which on further reaction with the NaOH rearrangement give the beta methyl heptone as the first materials. So these methyl heptones react with the used for the synthesis of the citrals. This methyl heptone reacted with the alpha iodo compounds in presence of zinc ester. A Reformatsky reaction takes place, give the product that is the intermediate of the above, and which on distillations gives the citral as the main products. This is the reactions. Do the practice of these reactions so that we can cover the reaction part. Next is the isomerism in citrals. Natural citral is a mix of the two isomers called as the citral A and citral B. Natural citral is a mix of the two isomers called as citral A and citral B. Natural citral is the mix of the two isomers called as citral A and citral B. They having the geometrical isomerism with reference to carbon C2 and carbon C3 double bonds. If the methyl groups and hydrogen atoms are trans to each other, it is called as citral A. If methyl group and the hydrogen atoms are cis to each other, it is called as citral B. Trans E forms citral A and cis Z forms citral B. The configuration is assigned on the basis of the following cyclizations reactions: citral A and citral B on the reductions with the sodium amalgams give the corresponding alcohol geraniol and the neurols. In the reaction, it is found that nero cyclizes at time faster than the geraniol. Hence, in neon, the alcoholic groups and other double bonds, some alkaloids occur as glycosides of the sugar, some as the amides and some as the esters. Alkaloids are the poisons in the nature but are used as medicinally in a very small quantity. Examples: glycosides occur as the glycosides of the glucose and aminoes in the alkaloids of the solanum groups. Ester, atempine, cocaines, amide, piperine, salt of the organic acids, opium, alkaloids, nicotines. Classification of alkaloids. Alkaloids are classified on the basis of heterocyclic ester present in the, also classified on the basis of the plant source. Type based on the heterocyclic ring example type based on the plant source. Pyrrolidine alkaloids is the pyrrolidine nitrogen containing examples type based plants. Pyridine alkaloids, pyridine, pyrimidines, heteroalkaloids. Next is the pyridines, pyrrolidines alkaloids. Pyrrolidines example is nicotine, tobacco alkaloids, tropine alkaloids, belladonna alkaloids, nortropane alkaloids, quinoline alkaloids, alkaloids, isoquinoline alkaloids, opium alkaloids, phenol, beta alkaloids, morphine and opium alkaloids. So these are the classification given. Indole alkaloids, geraniol alkaloids. Next is the Hoffman exhaustive methylation degradation in alkaloids. This is the important method for the structure determination of alkaloids by opening of the heterocyclic rings. Nitrogen containing compound contains with treated with the most Ag2O form the corresponding quaternary methyl ammonium hydroxide. On distillation, hydroxide ions and beta hydrogen atoms are lost as a molecule of water along with the fission of the carbon nitrogen linkage. Here the reactions given. Pyridine react with the H2, react and follow the step by steps. First in the react with the CS3, then Ag2O, then minus H2O, then react with the CS3I, then AgOH, and finally we will get the NCS3 as the final alkaloids degradations. Next is the for practice. Propidine undergoes the Hoffman exhaustive methylation dehydrations, gives the cycloheptadines, CS3I minus HI, Ag2OH, moist Ag2OH, and CS3 CS3 minus CS2O. In this way the reaction is completed. Next is the nicotine structure of determinations of the nicotines. Structure of nicotine is based on the following synthetic evidences. Molecular formula of the nicotine C10H14N2. Nature of the nitrogen atoms in nicotine react with the two molecules of methyl radicals to form the dimethyl. Therefore, both the nitrogens atoms are tertiary. Reactions is given to prove the tertiary atoms. On oxidations with the acidified potassium dichromate, nicotines gives the nicotinic acids. Next is the reactions of the K2Cr2O7S2SO4. Hence the nicotine must contain the C5S10N as the groups. Nature of the side chain. Nicotine ZnCl2 on distillation with the soda limes gives the pyridine, pyrols, methylamines. Reactions completed and give the pyrols. Thus the nicotine may contain the structures first and the structure second. Next is synthesis of the nicotine from nicotinic acids. This is synthesis parts. In these parts we synthesize the nicotine from nicotinic acids. Synthesis of N-methyl pyrrolidines, succinic acid, electrolytic reductions, pyrimidines, N-methyl pyrrolidines. Synthesis of ethyl nicotinates, reactions nicotinic acid react with the ethyl alcohols. Esterification give the ethyl nicotinate. Step 3 is synthesis of nicotine, ethyl nicotinate plus N-methyl pyrrolidines. Pleasant condensations give the products. After completions, these steps. This is all about this natural products of the citral. Next is the hormones. Hormones are the organic substances which are secreted by the ductless glands and help in the chemical coordination of the various processes going on the body. Classifications. There are four classes of the hormones based on the chemical structures. Peptides or the proteins hormones, thyme proteins releasing hormones TRH, insulin etc., amino acid derivatives, adrenalines, thyroid hormones, acyl acid derivatives, prostaglandin, stromal hormones, derivative of cholesterol, estradiol, testosterone etc., adenations, epinephrines. It is secreted from the medulla part of the adrenal glands, naturally occurring externally is the relating to the with the wild synthesis and is the arsenic. Next is the adrenaline epinephrine, which is the secreted from the medulla part of the adrenal glands. Naturally occurring adrenaline is the externally, while synthetic is the arsenics. Structure is given, epinephrine structure and non-epinephrine structures are given here. Uses and the functions. Main function of the insulin is the increase the blood pressures. Main function of the adrenaline is the increase the blood pressures. It is also used to stop the blood hemorrhage. Hormones is active only when given in the injection forms. Synthesis of the adrenalines from catechol. The catechol, when treated with the chlorosic acid in presence of the phosphoryl cholesterol, gives the adrenaline as the products. This is a synthesis of these reactions given. Oats synthesis. In this synthesis, protocatechol aldehydes can be treated with the SCl yield cyanohydrins as the products. Is the synthesis and reduction give the adrenaline as the products. Two methods are there for the synthesis of adrenalines. So this is all about the today's lectures of the natural products. In the next lecture we will cover the spectroscopy part. Thank you very much.